So welcome guys to a quick little video, and in this video I have made a light sensitive switch using a LDR and a operational amplifier, and it's quite a simple circuit, but it's a different approach to turn on and turn off the system. So in this system, the system is actually always turned on when it's powered, and when the darkness actually hits like this, you can hear the relay clicking. You can hear that. So it turns on. So we have to connect the NC part, normally connected part, and the NO part, and we have the main connection. So we have to wire this to the normally open, so that connects when it's get dark, and it turns on when it gets light. So this is quite a different approach to turn on the system, because I am going out for a couple of days from my home. So I want to light up my my garden area with the light, and if somehow the circuit fails to operate, so relay will always stay in NC contact, so that my system works. If the power supply fails or anything happens to the circuit, it will always turn off. So that is a redundant way to put this. So I will show you the circuit diagram first. So let me show you first. So in the circuit diagram that I have actually copied from this website that you can go and visit. It uses an opamp, operational amplifier, with a PNP driver. So here is the LDR that you can see, and this is the potentiometer. In this case I have used a 100k resistance with a 10 kilo ohm resistance in series, connected in such way, and there is the LDR, and in there I have used equal resistance of 8 kilo ohms both side, and here I have used 900 ohms. Two of the resistors, R3 and R4, both are 900 ohm resistance, connected such way, and here I have used BC558 to switch the relay. So in the circuit that you can see, when the LDR hits with light, its internal resistance will go down such that the voltage drop across this is the reference point. This is the plus supply and minus supply. It will make a voltage division at this point, and this comparator will compare the voltage across this point. So if the voltage goes down, so does the voltage of this goes up, and it reacts to the comparison of these two voltages. So by the primary time, the system actually takes the current, and it will actually be in the higher position, so the current actually flows. And when the LDR is being activated by the absence of light, the system is actually activated, then the relay actually operates, and it goes to the NC position. So that gives me an advantage if something happens to the circuit, or if something power supply issue or something happens. So relay will always stay in a normally closed condition, and it will power up my system actually. So that's a plus point. So I have used this approach, and I will show you the circuit, what components that I have used, and you can see there they have used, I don't know, 741 that uses actually dual rail. So I don't have dual rail, I have single rail, and I have scrapped everything from scratch. So I will show you the circuit again, and I will explain the circuit in my setup and condition, and how I made. It's a quick little video, so I thought I would make a video about this project. So in the paper, in the rough circuit schematic, I have used 8 pin LM339. Don't ask me why I have used, because I have couple of them laying around. You can scrap them from any switching supply or anywhere. So this is LM339N. So it has a quad operational amplifier, and there you can see the connection. So I have put everything in this order, and I have laid the circuit like this. And this is the plus volt supply, this is the plus VCC, and this is the ground part, and this is the relay coil actually showing right here. And so yeah, like this. So you can copy this and you can go ahead and do your own. But in my case I have different kind of PCB, so I have to drill out a couple of traces to get all the connection over here. It is the bodged out 100 kilo ohm resistance that I have mentioned, that is being connected from the ground part to the LDR supply. So this part actually has the, so this is the 100k, and in my case this is the 10k potentiometer. This is the LDR that you know, and this is the equal voltage. So I have, in my case I have used 8 point something k. Both of them are same because I have couple of them laying around on my box. And for this voltage divider I have used also nearly 1 kilo ohm resistance. You can use 1k. I have used 980 ohms. I have a couple of them laying around. Both of the resistance is the same. And this is the BC558. it's a PNP. So make sure this is the collector, and this is the base, and this is the emitter, sorry, this is the base, this is the collector, and you know that it has a PNP kind of operation, so it sinks the current. So the plus VCC come here and splits into the base and collector, and it goes over to the relay to activate. So this is the pin 1. So you can go ahead. I have made this with LM339, so it's a different approach, but it works, and it is currently on. And I have such a long wire, and I have put everything inside a small little transparent soldering wire can. So if I, you can hear the relay click when it gets dark. You can hear the relay actually clicks. So it is currently powered by 10 ohms and such. I just need to supply this with a proper 12 volt supply with regulated supply, and I have to connect this with the NC and NO part such way that my load gets turned on when there is darkness. So I thought I have to share this, so I made this video. That's it for this video. I will see you guys in the next video.